Hi, this is Ibrahim speaking, and on this video we're going to see how to graph different kind of functions. The first thing I need you to notice is that here I have three elements that I have already entered into Mathematica. The first one is a univariate function, the second one a bivariate function, and the third one a list of coordinate pairs. So what we are going to do is to plot in 2 dimensions this first function, and in order to do that, I'm going to use the function plot. The function plot, I open a square bracket, and I'm just going to say I want to plot f of x. And then, after saying what function I want to plot, I need to introduce what is the domain of the function that I want to plot. In this case, I open a curly bracket because it's going to be an interval, and I say I want x to be between, let's say, -5, to 5. I close the curly bracket, the square bracket of plot, and when pressing Shift Return, what I'm going to obtain is the typical continuous line of 10 minus x. Now let's imagine that this function is not continuous, but it is discrete. So what I want to see is a sequence of points when evaluated at -5, -4, -3, -2, and so on. The instruction is pretty similar. Instead of working with plot, what I'm going to add is the instruction discrete plot, and look carefully at how it's going to look like. Instead of the continuous line, it's going to look as the same, but now with dots. That is, I am not evaluating all the different elements that I have between the integers. The same happens for this multivariate function. This is g of x and y, and what I'm going to want to do is to plot this in 3 dimensions. So the instruction is, again, plot 3D, because now it's a 3-dimensional plot. I open my function and it is pretty much the same. I introduce what function I want to use, and then for the region I want to plot, now there are 2 variables that I need to specify. X, let's say from -3 to 3, comma, and also y, let's say from -3 to 3 too. When I press Shift Return, what I am obtaining is this 3-dimensional graph that I can click on it and rotate it to see it from different perspectives. What happens if I consider that this graph is not continuous but discrete? Pretty much the same. I can add the word discrete at the beginning of the function, and when pressing Shift Return, I have the same graph but now exclusively with points. Finally, as you can see here at A, what I have is a list. So I am not introducing the function with symbolic math. I am introducing a sequence of numbers, and I want to see how it looks like. What I'm going to have is pretty much a scatter plot. So for finding that scatter plotting, the instruction I need to use is ListPlot. This ListPlot will allow me, in this case that the list is A, to see how the points in the list are behaving. When I press Shift Return, look carefully how I have this behavior. There is a quadratic behavior of the points that I have on the list A. And these are pretty much the main representations and the main plots that you can use in Mathematica. Thank you so much for listening. See you later.